Let's continue with number 16 on page 283. This time we're working with a sampling distribution of sample proportions. So we have 3 births randomly selected. Sample space for the genders would be at what I have listed here. We have 3 boys, 2 boys and a girl, boy, girl, boy, boy, then 2 girls, girl, then 2 boys, girl, boy, girl, 2 girls and a boy, or this should be 3 girls. Let me correct that. Okay. And we're to assume that the 8 outcomes are equally likely and construct a table that describes the sampling distribution of sample proportion of girls from the 3 births. Does the mean of sample proportion equal the proportion of girls in 3 births? Okay, so if we're talking about proportion of girl in 3 births, each time that a baby is born, there's a 50% chance of the child being a girl. So the mean number of girls in 3 births would be 1.5. And 1.5 over 3 would give us a proportion of 1/2. So the proportion of girls, the mean proportion, this is for a population. Okay, so they want us to do so we can have the number of girls. Let's see, whether they want, no, they want the proportion of girls. Proportion of girls. We can have no girls, like in the case of boy, boy, boy. Probability of that is 1 out of 8. We can have 1 girl out of the 3, and the probability of that is 1, 2, 3 out of 8. We can have 2 girls in 3 cases. Probability of that is 3/8, so that's 2/3 girls. Or 3 out of 3, which would be a 1, and there's again only 1 of those, so 1/8. So this is what our sampling distribution would look like. And what they want to know, they want the mean of the sample proportions equal the proportion of girls in 3 births. So okay, so hang on just a minute, I need to pause this. I guess they're not knocking on my door. I thought they were. Okay. Alright, so if I add up these proportions here, I get a sum of 2, and I divide it by, there are 4 of them. The mean of my sample proportions, oops, my pen is writing everywhere that I don't want it to, is also 0.5.